We got a real simple demonstration of a Bedini SSG circuit with a generator or gen mode. So we got the two diodes, one with the negative and one with the positive, both for the output. So you get the negative spike with this setup. You think here. Currently, it's set up with the, this is a tri-filer coil. I like to think of the coil as the heart of the motor. Not so much the circuit as the coil. They work kind of hand in hand though. So, but it's got an 18 gauge drive, a 32 gauge trigger coil, and then a 20 gauge tri-filer. Now the tri-filer is producing enough energy to charge this cap bank noticeably on a 100th meter scale. So 0.00. This one, I believe it'll go all the way to 0.000. But this one's hooked up to the battery. And both the cap bank and this battery are charging simultaneously off the 12 volts that I'm going to put into the system. Now I tried hooking up the tri-filer strand to this other battery over here, and it does not charge at a rate that's enough. It's not what I would consider powerful enough to. The backlash of the battery is stronger than the energy coming through that. But if you hook it up to the cap bank, you get a noticeable increase in energy. And so far, all right, so now the output, which is containing the output from the collector and the negative spike from the coil collapse, is being put into this battery. And it's already charged up 6 100ths. So 0.06, 0.07 goes up pretty fast. And the cap bank is going up just as fast. But yeah, I don't understand why the battery doesn't go up. Here, let me turn these around like this. This is the cap bank. And this is the battery.
Hola, welcome in. Thank you for stopping in.
Hello, hello. Just doing a little nightcap here. A little breakdown of Bedini SSG circuit with gen mode. And what it's doing is generating energy for this cap bank and energy for this battery at the same time via different output in conjunction with this tri-filer coil. So the tri-filer strand is charging the cap bank and the output is charging this battery. And they charge it pretty much the same clip, give or take. I think that honestly, it feels like the cap bank charges faster.
Hold on, let me.
Oh, let me do it. Well,
Oh, it just looks a little distorted. I think I'm a little too zoomed out. There we go.
Could be very dirty.
Got it.
Okay.
Thank you for the likes.
Thank you. All right, so and that's pretty much it. I was also looking at another. There's a relay called the Bedini Bounce. And it basically just uses positioning to act as its relay, to act as a relay. I see a possibility for the 3-magnet 120-degree rotor to do the same thing with the coils at 180 degrees instead of 90. And that would be sweet because I love the 180 degree, the 120 degree rotor. I love this rotor. It's the sweet spot to have the 120. I mean, 180 is good, but I think 120 is better, personally.
We have Louisiana in the house.
Hey. So it's just a 3-pole, all north. Magnets in the middle on the rotor. I got a whole nother setup where the coils are in the middle, and it's pretty sweet. And the permanent mags are on the outside. I was thinking a way that I could put a permanent mag like such on the front of this coil and have my my other rotor up here. Well, I'm not going to do it, but you can kind of imagine. I want to demonstrate it, but I don't want that coil to fly, or this magnet to fly. So you put this in front to fire the reed switch that'll activate the coil on this rotor, and when that magnet activates, the electromagnet, would it be enough to penetrate this ceramic magnet and activate this trigger strand and fire off this whole system? Because it's if I can make the electromagnet fire the electromagnet, that would be like, I don't know, that would be phenomenal to me. That would be next level. And what I mean is, and I should probably get the other rotor out here, but I don't want to do that. Having this permanent magnet fire this electromagnet, which will then trigger this electromagnet, which will then add like astronomical amount of propulsion and speed and all that jazz, torque. I mean, the electromagnet on electromagnet should be like epic, but it's like, how do you make that happen? And in a proper timed, situation, and that's how you would do it.
Hey, Randall, welcome in.
But I think I need stronger magnetic field on my coils, like a more, I don't know though. I should definitely try that.
Thank you for the likes, everybody. Appreciate y'all.
Thank you. I'm definitely going to get that real quick, just to set it up real fast so people can see it. I need to see it now that I'm talking about it. And this is a very awesome levitating. See, so on the downside of this one, you got a toroid and then a toroid on the table, and they repel. I just need a few of these. Make sure that it doesn't attract to the magnet here. Well, it will attract, but it can't connect. So So we'll get it up like a little higher. And you can kind of see what I'm saying now that it's over here. Or maybe I was describing it well enough. I don't know. Alright, so there's 3 batteries on there. And I haven't decided which way is the best way to put the batteries on there. I might just make a whole new rotor. Should probably get cracking on that right now, actually. And have like a compartment, a little place, and a little slot for the batteries. So, what happens is the ceramic ferrite magnet is going to trip this reed switch. It's going to fire the corresponding coil, which hopefully has a magnetic field that will be able to reach this coil and fire its trigger strand. Okay? That's what we're trying to do. And then this will have a corresponding burst of speed and torque, and both of these mechanisms will be functioning. All it has to do is penetrate this ceramic magnet and trigger this trigger strand. And then the Bedini will fire.
Bedini. Thank you for the likes. Appreciate it. By the magnetic field.
But I think the magnetic field is lacking a little bit. And it may be the way that I wrap the coils, because I taped each layer to try and get maximum uniformity. And it didn't work out the way I wanted. It was okay, but it didn't work out the way I wanted it, and now I got a layer of tape between each layer of coil. Which I don't know what the effect of that necessarily is. Could be a good thing, you know. Might not be a bad thing at all. But you know, I'll demonstrate this real quick.
Hey everybody, welcome to the channel. Thank you for dropping in. Let us know if you have any questions. Like and subscribe.
See, so that was on the wrong way for this to work right. You saw how it got sucked right in there. That is a pretty powerful magnetic field.
Do got a question? What are we looking at in layman's terms?
We're looking at a pulse motor that's riding a pulse motor, basically. We were looking at something a lot simpler just a second ago, but I had to go and get over. But this is definitely. Here, let me turn it on, and we'll see if we can't. Get that reed switch to fire.
Humming. It's buzzing. See if I can get a close up there.
Doesn't want to fire now.
See that arc? Thank you for dropping in, everybody. Appreciate it. Like and subscribe. Let us know if you have any comments.
See, it should be pushing it though, like away from. Yeah, that kind of worked.
What is a pulse motor?
A pulse motor is a motor that's, I would say it's based in a binary language, an on-off, any kind of on-off sequence. Like this one isn't working very well right now.
Self-propelled motor to create power moved by magnetism, question mark?
I don't believe it's self-propelled at all.
Okay. Yeah, we're usually spinning it and then having a little bit of input power.
Like, see, there's 3 12-volt battery packs on this one. I don't think it's self-propelled. Unless the battery is considered part of the system.
You're welcome.
But everything else sounded really, really on. Right on. Oh, but you can see it now. Like, it'll get to the one that's on, but it's stuck on. It's shorted out. So it won't go past.
Oh yeah, you can see it kick. Thank you for the likes, everybody. What service do the batteries hold?
Well, the batteries are each hooked to each coil, and they each have their own reed switch. So they're each parallel connections.
And you can see the coils are within the rotor on this setup.
Yep, that's where they're at.
The magnets on the outside.
But I think, here we go. It's kind of working. That was just one proper function of the reed switch there.
Saw it. Yeah, it's arcing. There it goes. It's doing it.
Yeah, it's not. It's like stuck.
Alex says it's 2 a.m. here in the UK, and I have no idea what I'm looking at.
All right. There we go. So these are all homemade contact reed switches on each one of the coils that are embedded in the rotor.
It's pretty screws and copper, pretty much.
Just screws and copper wire, little brushes.
And then they're connected to batteries, so the power itself is
On the rotor itself.
stored and on the rotor as a load.
It's not a load. There's no load.
Oh, I mean as a weight on the
Oh,
rotor.
yeah. An electrical load.
And it's having massive impact on the spinning currently. I wouldn't say perpetual motion. I think we're more along the lines of experimentation and discovery.
Yeah, definitely. I just barely discovered how to build one of these things.
It's pretty much to generate power in the spin and utilize all the forms of power going through the system in different ways.
Good news is that the magnetic field, once I get the homemade reed switches working, will penetrate the ceramic magnet and activate the Bedini. I just turned it on and it will activate. Will it run? I don't know. And what we'll have then at that point is electromagnet on electromagnet. And it should be awesome.
Hey everybody, thanks for stopping in. Welcome to the channel. This is Papa Bale. I'm the camera guy, Christopher, and we are working with pulse motors this evening. This is an experimental where the coils are embedded inside of the rotor. We have a storage mechanism for power input on top of the rotor. And then we're using this powerful magnet.
Wow, it just gets two.
Leaned up on the coil as the magnetic propulsion mechanism. Let us know if you have any questions. Drop us a like and subscribe if you like the DIY kind of content like this.
Yeah, hell yeah.
Jesse, just the batteries hooked together on the top here. So these are 312 volts.
They're not hooked together.
Oh, my bad. They're hooked to the coils.
Yeah.
Excuse me.
Each coil gets its own battery. There's only one coil hooked up right now. And that's probably what the whole issue is. Just this one.
Yeah, yeah. He was mentioning the next problem is when it starts to spin fast, the batteries will want to fly off. Yes, indeed.
That's so true. That is so true. That's why I was thinking about making another rotor that has, space for the batteries and have smaller, lighter batteries.
Or insert them inside of it as well, kind of thing.
That's what I meant.
Yeah.
You have to make a special compartment for the batteries. There's not enough room to put them in the holes. Even if you split them in half.
Prop guru, you're using handmade reed switches with screw and copper for this build. But we do use Hall effects, yes.
Yeah, I got a whole hook over there full of burnt out Hall effects.
Thank you for the like. Appreciate you guys.
Yeah. I'm gonna have to remake. Which one is it? It keeps hitting this one right here with this screw right here. Because it sticks out too far.
Oh, we got a mention of the old magic trick where rotating magnetic fields keep a spinning top going for ages.
Oh.
And I think you can even levitate that top.
Well, it's not. It's along the same idea.
Oh, okay. I get what you're saying. So that's the levitating one is something completely different.
See, this is supposed to be just like that. And then you spin it. It's supposed to be a counter-rotating pulse motor that spins like a top for as long as the batteries go. But it's a little different than what you're talking about. But you said top. I'm like, I gotta show them that.
All right. Damien asks, hey, I'm kind of new. What is the end game to your creations, or is it just curiosity?
Curiosity and expansion. I don't have an end game necessarily. Everything kind of changes a lot, sometimes a lot in every show. I'm having a ball as long as I don't like die doing something. I'm pretty much. I mean, for the sake of completion, I haven't done much. I've completed maybe 3 or 4 projects, and they're all counter rotators. But I've cannibalized most of them already. Like this one underneath the table was my latest one.
Thank you guys for the likes. Appreciate it.
All right, so yeah, I need to change up that one.
You can see it arcing, that green hue.
12 volts might be too much for this particular build.
Faraday Research says I use 3D printer proximity sensors.
Nice. Yeah, I think those are the same ones I use. Are they like the 5JK 500s or something like that? Are they like for a specific brand? They're bigger than most Hall effect sensors.
Oh, cool. So Prop Guru explain that top design here. The base houses a 9-volt battery, a coil, and Hall effects. The top has a ring magnet in it. As the top spins over the center of the semi-concave base, it switches the coil.
I don't even know if a schematic could like get that picture in my head. I don't know what you're talking. I don't understand.
Welcome back, Tech.
Hey. Yeah, I mean, and the more precise it has to be, the less likely it's gonna happen.
Are you a fan of the Thomas Townsend Brown? I'm trying to recreate the Brown's effect.
No, I'm not. Sorry. I
Uh,
apologize.
Go to our homepage on YouTube and look in the About section. We have some contact information there.
I might have to just redo the style of switch entirely because it's just a little bit of wire that sticks up. The concept is sound for it to work right. So, you know what? When it was working before, and I got 2 more of these over at the storage place, but I had them stacked up like this.
Okay. Now, does that double?
The strength?
Yeah.
Yeah.
That makes it, well, yeah, it's twice the size. Well, could be some kind of awesome calculation that's like it amplifies it or it takes a little away. I think that's cool. Hey everybody, welcome to the channel. Thank you for the likes. We got 10 likes. Let's see if we can get it up to 20. We appreciate you guys. Drop us a comment if you have any questions about what we're doing. This is Papa Bale's Pulse Motors channel, and thank you for dropping it.
Oh man. And, anybody got any ideas on materials that I can use, like household materials, to make a good magnetic switch? It's like better than like copper on copper. It sticks too much.
Discord link is broken. Is there the link to the X account on there?
The Discord link is broken.
Yeah, we got feedback
Got
on
to update it.
that. Yeah.
Okay.
Okay, and the X doesn't work also, so we'll get on that. Sorry about that, prop. As soon as we get that up, you'll be able to send it to us. I'm so sorry.
Weird.
Yeah. Wasn't aware of that, but
Yeah.
appreciate it. Yeah, the top. Because the one I was talking about when I was a kid, we had just bought one of the ones that levitated. And I thought that was cool. Thank you for the like. Appreciate you guys.
God, that is so annoying. I just want to move it up like a millimeter, and it's stuck on all the glue.
How much power does the material need to carry in amperage?
For what?
You talking about for this one to run?
It's probably carrying too much right now. It's running 20 gauge, 4 layers on a 3-inch, 3/4-inch diameter, 3-inch core. So it's very little wire right now. And it's 20 gauge. Like I'm saying, it's probably drawing way too much because it's.
Oh, he said for your switch because you said the copper sticks too much.
Yeah.
Mm-hmm.
What's going through this system right now is way too much for the switch.
Welcome in, Mike Does. Hunter says, need a clamp? Why do you have one for us?
Actually, if you reverse the toroids, underneath,
like flip it upside
if you
down.
flip this one over and you stack up some bearings, this will act as a clamp. It'll clamp it down and it'll hold it steady on the pole.
Oh, the magnetic clamp. That's right.
Yeah.
Do you have any ferrous bearings or steel BBs? And then Orkford says, "What's up, Papa? What are you cooking up tonight?"
We are trying. What we're gonna do. What the end game of this is we're gonna have this permanent mag stack use these reed switches to fire these coils off of these 12-volt batteries, right?
Mm-hmm.
Then these tripped coils is gonna fire this coil. And if I have it set up right, that'll be north on north.
Okay.
Okay? And when I turn this on, well, if I haven't blown it already, oops, and I have all three reed switches firing like accurately. I don't ever see this happening with the copper on copper though. And then turn it on, it should be electromagnet on electromagnet.
Top Guru mentions trying 9 volts. Didn't you have that set up?
Yeah. 9-volt right here. 9-volt.
Oh, yeah. Hey, everybody, welcome to the channel. Thank you for dropping in.
I could do that.
This is Papa Bale. I'm the camera guy.
Papa Bale, camera guy.
We're
in the house.
working with pulse motor experimentation.
I even
Please like
tried
and
to
subscribe.
hook this up on it. It's a little voltage potentiometer, and then have it way down on the low. But I mean, 12 volts, like it's even when it's off, and you click it and it clicks off, it's on.
Luke's like, try 72 volts.
Oh, I got something that'll, this right here will jack it up to 345 volts.
Yeah, I've seen you using those.
Oh yeah, that's really fun. I think that'll be an interesting. I want to make a better switch. You know, I was watching Beats show, and he made this awesome switch that doesn't stick at all, barely ever, and it's very fast in its frequency. And I want to make the switches respond like that. They got to respond like that, or this whole idea won't even float. But it will trigger. The trigger works. It's just it needs a constant. It can't be all jalopy.
So following up on the copper sticking piece, Damien mentioned brass makes a very good contact, but depending on the amperage, can fuse itself together. Can fuse itself together. However, tungsten works absolutely great.
Okay.
And not fusing together, and it's impervious to electromagnetism.
Yeah. Can I get it in like I need it like in a paper clip, a tungsten paper clip. You know, I need it really thin. Or I mean, the contact needs to be like plate style, I guess, if it's going to be tungsten. And it should be really thin and really small. Like, should be that smaller than that and thinner than that too, like a lot thinner than that.
So Faraday Research says most bi-coils I built for my pulse motors are at least 1 pound to 2 pounds in weight. Very large, and you get a lot better results on back EMF spiking.
No, that's totally right. And I've made a few big ones. And you're totally right about that. Let me get the. I mean, this one right here is 1,500 turns of 20 gauge, and it's 1.5, maybe 2 pounds.
Oh yeah, that's 2 pounds for sure.
But it's not a small coil. It's a 20 gauge.
Right.
So if you're talking like a 32 gauge coil, that's 2 pounds. That'll be a little smaller than this, but that's a lot of wire. That's a lot of turns.
I zoom out too far. It doesn't give me the lines, but I'll notice if you're looking all super tight and thin. Prop Guru says even over-the-counter reed switches can't handle current mostly. Most will fuse about at 200 milliamps. I think we've run into some of that, but he's worked magic.
Yeah, man. I mean, and really, it depends on the fuse. I've had better luck with the thicker gauge ones and their ability to unfuse with the magnetic just by moving it a little bit closer and having the magnet pull it a little bit more.
Faraday says I use 24 gauge wire.
24 is good. I got a nice 24 gauge coil over here. It's a 2432 bifilar.
Hey Joel, welcome in. Thanks for dropping in. Let us know if you have any questions.
I got it all the way done, right? And there's my 32 and my 24. And then there's my 24. And there's still a little bit of an end there to work with. So I don't know exactly what to do, but I know that as long as that end is sticking out there, I can save this coil. But this is the beginning. Okay, so it's not like I can unwind it to save it. I got to make an extension, like a solder extension for that wire. But it's like right there. You can still see it shining a little bit in the light. But yeah, I've had a lot of luck with 24. Had a lot of luck with 26
Sorry.
too. Yeah, it's all right. It's all right, bro. You okay?
Mm-hmm.
This right here is 26 gauge. 6 parallel strands of 1,000 and 1 strand of 1,030 gauge.
Then Faraday says, and the input voltage I use for my pulse motors is minimum 24 to 50 DC.
That makes sense though with the bigger coils, and especially if you have more than one, you're gonna need to up that voltage.
And Prop says I personally like the 3-pole reeds.
Are you talking about the normally closed, normally open reeds in one, like the two-way reed switches?
And then Damien says I do a crap ton of different type of welding, from pipeline to underwater. That's cool.
Yeah.
To exhaust pipes. TIG welding electrodes. You can get a pack of 11 different size rods that are about 10 inches long. I used to vape and I had the big mods, and I made my own coil, so I ordered my own wire so that you can order tungsten nichrome in multiple different sizes and comes on a spool. Good job getting off vape.
Yeah, man.
You know it.
Bravo.
You know what that's like.
I smoked for 25 years.
Orgford says, what is your HZ?
My hertz,
Hertz, yes.
my frequency on the pulse motor, we could check that out. I haven't looked at it in like a long time. See, but this, it's got a lot of bounce here, a lot of leverage. Like, it's very smooth, and there's a lot of friction that is reduced by having it be levitated It's not all gone. Like a magnetic bearing would be like all gone, but it's like, it's better. This will spin for a lot longer period of time. And then my 9 magnet rotor will spin forever.
Thank you guys for the likes. Appreciate you guys.
Thank you.
Prop said, yep, that's them. Got any turbo and cabulators over there? What's your name on Discord?
My name? Papa Bale.
Mike does says Papa Bale is in the rabbit hole matrix.
I'm a gatekeeper to the rabbit hole matrix.
Oh.
See, now the rotor with the electromagnets on it could fire the Bedini like this thing is. Then you get the force on force, which would, I think, make it go like a lot faster.
Jason popped in and asked if we were trying for perpetual motion.
Always trying for perpetual motion. The keyword is trying.
And Mike does says, what up, Morpheus?
What's up, though? Oh, dude. Yeah, I was talking with a buddy about Chronos, actually. Father Time.
The Titan.
The Titan Chronos, Father Time.
Mm-hmm.
And how, you know, just his influence existed beyond his imprisonment and his ultimate destruction. It's like, but the real like 0 point in here is like about time. Do we leave an imprint in time? What is time? I mean, we have a memory, so that alone is proof that there's a past of something. Not necessarily like it happened prior, but the memories that we have of things that happened recently, or especially for people who smoke weed, are a lot more clear than the memories that are long gone. You know, things can be distorted and, you know, not be exactly what, you know. The question is there really time? Like, do we leave an imprint on time, or does time leave an imprint on us as we move through whatever this is?
All right, fair. Prop Brewer says, I think I just sent you a request on Discord. We'll check it out. Thanks, buddy.
All right, cool. I'll get that fixed for who's ever interested. I won't.
Faraday says, I use ceramic bearing so it doesn't interfere with the magnetic field or create any kind of cogging when the wheel is spinning at high speed.
Yeah, I use some ceramic bearings. I have, I forget what they're called, like R188s or something, Z188s. They're the little ones for the 1/4-inch poles. Like my 9 magnet rotor, this one has a ceramic bearing. They do work very well.
And then Orc4 says, check the hertz, bro.
Oh yeah, yeah. First I gotta find out, because I think the thing's hooked up to the battery right now, so it's not gonna give us a hertz reading.
Oh yeah.
I don't think it'll give us a hertz reading to the output either, but we'll check that. You know what we're going to do? We're going to hook it straight to the drive. We're going to get the hertz off the drive with the 1 meter.
Get the whole lab here.
Here it is. Now I might not be able to do this. We'll see. But there might be like some.
Time and gravity are the same. Yin and yang. North pole, south pole. You can't have one without the other. Be intertwined on a quantum level. Project Blue Book.
Time and gravity sound like they could definitely be on the same wavelength, but people like to put time and light on the same wavelength. But I think what light is just a way to measure all that crap, so you can see it visually. I don't know, like, I don't know what. I mean, I don't know anything about it. I just know that I don't think time and light. It's more like time and gravity. That sounds more like a synergy point to me. Because you're right. Binary systems, binary language, binary is definitely a way to go. North and south. I mean, even east and west is a variation of north and south.
Mike Dust says time is a radiation factor.
I thought time could also be the rate of measurement as well, like a rate of decay. Measure how much something decays is an indication of how old it is. You know, something like that.
For sure.
All right, where are we? We are hooked up to that. Let's hook up to the trifilar. Oh, we don't have a hertz reading for the other monitor, so we'll just leave this the way it is. We'll put this.
Stars are supercomputers running on nuclear fusion. Rock and roll.
Amen.
And that comes from world record rapper.
Cool, man. I dig it.
Joshua popped in and asked, what is going on here? What am I looking at in simple terms?
Wow, it looks like we got 3.5 kilohertz, and it's off. That doesn't seem right. Let me turn it on and see what happens.
Oh, yeah, I bumped to hertz. Oops.
Yeah, it's about 170. Maybe in between 170 and 150
For the hertz.
for the hertz. And that's for the drive, the 1 millimeter drive. I could definitely hook it up to the trifilar strand and see what the frequency of that is.
I think you pronounce it Calapagian. Said, I think the sun might be sentient. I think you might be right. I am a dwarf star. Thank you for the like. We appreciate you guys. Like and subscribe. Let us know if you have any comments.
All right, so black. Goes here. And since these are both like hooked up to cap banks and batteries.
Welcome in, Rodriguez. Thanks for dropping by.
You gotta hook them up at a certain point, or they're just gonna read the cat bank or the battery. Like this, I'm not sure. Let's see what it says.
Brazil is the house. Welcome in, Juliano.
Um, hmm. Cause that seems a little low, doesn't it?
Mm-hmm.
Like 170 was low, and then it's 170 again. But that's what the meter says. And we're reading off the ends of the coils before they go into any circuitry. So that's funny how they're reading the same. Oh no, this is a little higher. This frequency is a little higher.
So Joshua came in and said, quartz is an amazing tool to hold info and generate energy when paired with magnets and copper. But I know you guys know. We do know. And here is some right here.
Yeah. Well, we've been experimenting with it.
Yeah, I believe there's so much energy and power held in stones.
You know what we could do, if everybody doesn't mind, I could hook up a signal generator and we could mess around with this 20 gauge 1500 coil. Oh, what time is it? Like, what's our clock?
We're at 52 minutes.
Oh, maybe another time.
And it's 9:30.
And we're about at 200 hertz now, and it's stable. It's getting stable. That's a good freaking reading right there, man. That is stable as a rock.
We live in Metro Detroit, so there's a lot of local cities
Wow, that is
nearing
amazing.
that. Yeah, I like that entrainment tone for meditation for sure. Appreciate it, Joshua.
There's one more thing I'd like to try here. I'd like to swap out the 3 magnet rotor for the 9 magnet rotor.
But the vortex coil, that one I haven't heard of. Have you heard of a vortex coil in a while?
Yeah, I've seen a vortex coil.
Okay.
It's a very interesting design. The geometric vortex coil, right?
And he's saying as an aid during meditation.
Oh yeah, man. There's a SNQ sells that stuff.
Okay.
And I've been meaning to pick up on at least one of the orgonite items, and
I know we got some orgonite in that black pyramid back there.
yeah, I noticed that.
Mm.
And then the tricyclicon and tricyclion.
Yeah. I love those shapes, man. And they're ancient.
All right, so now we got the same levitation. We got ceramic bearing. We got 9 magnets. The rotor itself weighs about 2 pounds. It's 100% PLA print. So 15% PLA print weighs less than 100% PLA print. I can attest to this. 100% true. 85% more PLA was 85% more. Absolutely. I guess it depends on what you're measuring, but this is definitely 1-to-1 on the increase.
So Joshua said, I've had a hypothesis about magnets being embedded in the roads, and magnets with opposite poles mounted under cars. And the poles push the cars from point to point like painted coatings.
Yeah, that's interesting. I think that sounds pretty cool.
So there's no ride disturbance, but speed regulation is wired.
I've also had like many thoughts about magnetically propelled transportation. I was thinking about using. See, there's got to be a way, since the Tesla coil's energy is so radiant, to pick up on that radiant energy, the radiance, just the radiance, and capture it and store it and be able to use it. And I'm not going to give up on that being a possibility, man. I mean, I got a bunch of no's today, but I'm not going to let it get me down. I kind of keep focusing on this. Now, I know there's a lot of things that aren't compatible with the Tesla coil and, pulse motor. But there's got to be some things that are. There's got to be, and, I was watching a program on YouTube a while back about wireless, like remote control, wireless technology. And I mean, if it's infrared, then it's infrared. We got to use. But he was using coils. He was using.
He's like, awesome. Take it from unlimited to a stored potential. Nice. So, yeah.
And yes, you've got to be able to. There's got to be some way. And I think it's coil to coil. You can do it, and you got to have a reverse Tesla coil. That's the thing. You got to have one that can suck it out of the air, the radiance from the other Tesla coil, and transform it into what it was before it got put into the Tesla coil on the other side.
So that's one of the documents that was in one of those chests that got confiscated.
Is it now? But that makes sense, doesn't it? You can use the same text somehow. You got to be able to reverse not just the polarity and flip the fields, but you got to be able to reverse the energy from radiant back into AC and DC somehow.
Like an alternator that's backwards.
Exactly. And then you just put the two face to face, basically, but they don't need to be face to face. They can be anywhere, and that's the whole point. And I think the documentary about the missing chests, they did a.
He said makes much sense, my friend.
Yes, it does. They did a Tesla coil experiment in that same documentary where they ran a motorboat in the water off the power of the Tesla coils, and I think they used capacitors, and I don't know what they used to transform the energy back into AC and DC, but
that's right, Joshua. Yes.
I should probably look that up because they've done this before. Like,
now the confiscated is the conspiracy here. Was it Trump's uncle helping Tesla, or was it all government?
oh man, it's a good question. I don't know personally. Like, one way or another, I do know that those some of that material was taken by the feds.
Yeah, and Josh said, I don't know, but I'm right here with you. Yes.
Yeah.
Thank you for the likes, everybody. Appreciate you guys.
But that electromagnet sounds really fascinating to me, and I'm going to continue to work on that project. I might have to make the coils, and I think Mike Faraday was right about me needing to make those coils a little bit bigger. They need to have a little bit more meat in them, and then they'll run a little bit smoother. They won't arc as much. They'll probably have a bigger magnetic field too, you know, and probably all be good. But I mean, it does function. It functions rather well, except for the fact that they stick together. I might need a tungsten switch to make that work. And I love this thing, man. This thing just cruises. And it seems like it's a little off balance, and I think it's because there's two magnets in there that won't come out. I mean, they literally won't come out. I hammered them in there because I bought 2 more cubes, and cubes are expensive, man. And these big ones that I'm using, the other big ones, they're expensive too.
Yeah.
It's like $40-50 a time you buy a magnet. You only get 2 of them.
And now with this trade war going on, they're going to be $50-60 a magnet.
That's right, and that's oh man.
Page 6 it says she's coming home. Joshua, thank you for the compliment. You guys are fucking dope.
Heck yeah.
I really appreciate the engagement. Thank you for dropping in. Let us know if anybody has any questions or comments. Please like and subscribe.
Thank you very much. I really appreciate it. Giving me a lot of good ideas. Oh man, I'm like, now that I got the idea, I don't want to put it down, let it go. It's like I want to continue. But right now, currently, I don't have anything to make the switches better. Oh, yeah, I wanted to show everybody this, and maybe they could tell me a way to make it work better. This here is a Litz wire coil. It's 100 strands of 38 gauge. And I'm trying to, it's a high frequency Litz wire. And I think what I want to do is hook this up to the signal generator.
Later, Mike. Thanks for dropping in. Good to see you.
Thanks, Mike. So yeah, this will be neat. Definitely want to hook up to the signal generator. 100 strands of 38 gauge. All twisted up. I love how smooth this one runs. Let's see. 9 volts, 9.62 volts. Huh.
What are your thoughts on the Liberty Engine version 2? Free energy generator, 20 kilowatt with microwave transformers.
Well, I don't know anything about high voltage, but I'm gonna learn here sometime in the near future. Yeah, I don't know. How can you work it by plugging it into the wall? I don't know much about it. But I think that's how much AC we're getting off the trifilar strand right here. It's 5.5 volts of AC electricity.
Got some good data.
Heck yeah. So if I was going to buy some wire to make some coils, like bigger coils for the other rotor, what gauge would I buy? Like if I was only going to buy 2 spools, 3-pound spools, and make bifilar coils, what should I buy? I never know. I never know for sure, but I like this one, the 18, the 20, and the 32 was an impulse. And I just said, hey, we're going to go for it. And it ended up being pretty strong. I mean, it's a tiny ass coil. It is very small, but it's powerful.
Thank you for the likes, everybody.
It's powerful on the one end. Okay, it's powerful on the spinny end of things. Like immediate. It's low energy. Okay, you don't need. You can do it with a 25-volt power supply. And then you only need 12 volts to get a decent output from this. But I understand, like I think it's inductance, right? You need more layers to produce more inductance. And then if you look at it as each strand or each layer of strands, like each layer of winding gives an imprint that is forced outward. And so literally how uniform and how you wrap your coil is literally how it's going to expand outward. So if you got kinks and, bends all up in your coil, that's how it's going to look when it expands outward. Because it really does like imprint exactly the way it is. And all the way up to the transistor, this imprint, is. So if you bend your transistor, you got a bend in your wire. You do. But, I think some bends are okay and give your coil character. But if you're going for something, if you literally have parameters that you need to follow them. It's the only way to go, man. It's like literally if you're 3,532 feet of 32 gauge wire, then you need to find a way to measure that all out before you start wrapping your coil. And you need to have it all on a separate spool, all wrapped up and ready to go. But you need to measure that out before you start wrapping your coil.
Nice explanation.
Yeah. But like me, I never had a guide. It was all freestyle for me. So I have my spools actually set up on a pegboard that I'm going to like incorporate into my coils. And then I just, depending on which winder I'm using, wind them all up parallel, basically. Like when I'm doing Litz wire, there's a hole in the wall where I put this. And I go from wall to wall, and I make it's 16 feet exactly. And I measure out however many 16 feet wraps I'm gonna have, and then I do the math, and then I hook them up in series, and then it ends up being 260 feet altogether, or something like that.
Everybody, thanks for the likes. Let's see if we can get it up to 30 likes. We appreciate you guys. Like and subscribe. Leave any comments if you have any questions. Oh, Claire, we used to live in Houghton, Hancock, Michigan for a while. For like 15 years.
Yeah. Yeah, we lived up there for a while. Yeah, I'm very happy with how the SSG circuits work. From the kenergy.store. There's one right in front of you. If you want to just zoom in on that real quick. And it's got the gen mode. So I've been able to charge both a cap bank at 16.2 volts, 500,000 microfarad, and I've been able to charge this battery for, it's, I don't know if it really holds the charge though. I mean, I charged it, I guess it does, to like a 10th, but I've charged it that 10th like 8 times, and it doesn't maintain the charge as much as you charge it. I don't know why. And that's for the spike and the gen mode output. So it'll charge up to 12.8, and then it'll drop back down to 12.55 over time. It won't go below 12.55, but it'll drop back down to 12.55 over time. So what I'm saying is that there's nothing sucking the energy out, or it would continue to suck that energy out below 12.55.
Yanni says, nice. I am in Australia.
Nice.
And I pay for electricity. LOL. And fuel. That's right. Do you guys, is it per liter there, or do you guys do gallons?
I will be right there.
The straight dope says, yo, yo, Papa.
Yo, straight dope. Man, what's up?
Liters. Yeah, I bet it's like $5+ for a liter. Ooh, rattan.
Wondering what this is, huh? I gave my daughter a bet. I'm like, you do this for a minute and a half, and I'll get you a big gift. Do it for a minute, I'll get you a little gift.
Ooh.
And this one generates more electricity than the 9-magnet rotor does. And the reason for that is how much faster it goes. Like 9-magnet goes at a max 500. Now that's kind of freaky. It's kind of popped out. So I want to back this out to like a fringe effect. So it's just barely getting the core. You know, you can feel when it's knocking the core. So when it's just barely knocking the core. And that way you're going to get the max speed. You might have to push it in a little bit to when you start it, but I don't think you will. I could probably back it out even a little bit more, and I probably will once it gets going. Because the faster it goes, the more the field will expand outward.
Awesome. Damien's from our area, from the Western UP. Or, well, spent a lot of time, teenage years. Marquette, Gladstone, visiting friends in Calumet. Oh, swimming in Loch LaBelle. Yeah. What is it? The Bear Belly. There's a nice bar out there.
You get a rhythm, right? You get a rhythm going. And you can get going really, really fast. If you haven't done this, you'll feel it like within 30 seconds. You probably won't even, 30 seconds is a long time if you haven't done
Hey, Papa, I was talking about you the other day. I had to go to the end of the earth to find that live.
it.
You were rapping the brass ankh, making it ring.
Yes. Yes. Yes, the end of the earth, man. 5 miles past the end of the earth. I got that postcard, you know.
Houghton. Yeah. End of the earth, 2 miles. Houghton, 4 miles.
Yeah. Awesome.
Do not know Darcy. Because we kind of moved. I was 21 when I moved up there for school. I think he was 23. Yeah, there's a lot of lives. We're doing a lot more lives, so nice searching. Glad you found it, and we'll make some more content like that for sure.
Heck yeah.
Hey everybody, welcome to the channel. Thank you for dropping in. Please hit the like button and let us know if you have any questions about the pulse welder build for this evening.
We got a 3-magnet rotor, all north facing. We got 4 ferrite. All right, so when I backed it out, it actually increased speed a tremendous amount.
Mm-hmm.
That was pretty epic, man. It started like rattling. I'm not sure what that was. But it was going so fast. I think there's a little give. Because, I mean, the bearings and then the size of the poles don't always match up, especially when they're tiny, like a 1/4 inch. So I think there's a little bit of give. So when it got spinning really fast, like any vibration whatsoever, when it would touch the sides, would make it rattle. But yeah, I don't know. I don't know, honestly. I thought that was pretty neat, though.
Nice. I used to work in Lansing, the capital of Michigan, for the state house rep of the Western UP, the 110. So we got a lot of, attention, and we were shown a lot of different places, and Mount Bohemia, Mount Ripley, the ski jump. Yeah, my friend lives up there, right next to the Quincy mine,
Oh, yeah.
down in that neighborhood. Yeah, in the ski hills, Mount Ripley.
Foster Road, or Forester Road. Foster, right?
I learned how to snowboard on that ski hill. That's a steep one to learn. And I'm 42, he's 44. So same age bracket. Hey everybody, thanks for dropping in. Drop us a like, subscribe, let us know if you have any comments. Thank
This
you.
thing get going super fast.
Thank you for all the likes, by the way.
Thank you.
We appreciate you guys.
So we're at 4.7 volts now. 4.8. Oh wow, we just dropped a bunch. So maybe we're good. I don't know. But this is still the tri-filer reading. Wow. All right. So
Yanni said all the good stuff is gone in Australia way too fast. No kits. The parts are sold out. All good stuff gone. Laughing out loud.
well, that sucks.
And with these trade deals going on, oh my goodness.
12.9 or 4.9. Oh, 4.93. 4.94. 4.95. This is definitely an indication of increase in speed. 4.97. Oh, 4.8. 4.4. Oh, what's going on, man? Because when I turned it off the last time, it had got up to like 6 volts. It was going like super fast. I don't know what happened to make it go so fast. But it's definitely not going that fast right now. You know what I think it was? And I'm just going to try this. All right. Now, I don't know what just happened. I think it was when I touched the wire, honestly. So that might be what did it the last time too. Kind of like grounding the transistor. Let's see what happens. And then after this last demonstration here, I'm going to call it for tonight. So I pushed it in, and now I'm going to pull it out. Once it gets going a little bit. Yeah, it's up to 5 volts, 5.3, but I think I'm too close.
Yeah, the Hungarian Falls, very beautiful area. I'm trying to think of the name of the outfit that I'm on their email list, but they definitely do a lot of work there. That might be something to send their way. Do a documentary on it.
Well, it's all good. I think didn't react the way I thought it would, but you know, it says 5.2. I can back it out just a little bit more. Because when the coil's up close, it puts a drag on the rotor. So you back it out to reduce that drag. but when you back it out, you get less effect from the magnet. So it's a happy medium, but I think when this gets going faster, it's going to compensate for that loss from having it backed out.
Yeah, Damien, it's called the Keweenaw Land Trust is the name of the outfit. Check them out. Get on their letter and send that through.
That's very cool. All right.
Thank you for the like.
Put it in there real close this time, and then we're going to shut it down. You can hear it though, it's humming pretty nice.
Mm-hmm. Thanks for coming by, Josh. Appreciate you.
Thanks, guys. And that's very stable with the amount of energy that's coming out. It's 5.466. So cool.
You're good, Damien. Don't worry about it.
All right. Thank you very much, ladies and gentlemen. Peace out. Have a wonderful night, and we'll get back to you.
Thank you, everybody. Take a look at our channel, like and subscribe, and we'll see you next time.